Hello guys, welcome to this new session of DIY Guru where we will model ultra capacitor using Simscape block sets. So this is the model of an ultra capacitor. Within Simscape model, this ultra capacitor is provided, but in the name of supercapacitor. This is the supercapacitor. So this supercapacitor block represent an electrochemical double layer capacitor, or we can call it as ELDC. The capacitance value for capacitors are many orders of magnitude larger than the value for regular capacitors. Supercapacitor can provide burst of energy because they can change and discharge rapidly. So we will see how we can model this. So for that, let me minimize this block and just let me clear my workspace and also clear my command window. So to open a new Simscape model, blank model, what we will use ssc_new, this command. So just entering this command, a new window has been created. We will model our supercapacitor or ultra capacitor here. So before modeling, just let's fetch all the required blocks. So first we need supercapacitor. So for that we can search here in the library browser. Here we can search as supercapacitor, or this is the supercapacitor we will take, or we can simply write it here supercapacitor and we can take that as well. So let me just take this. So I have taken supercapacitor. It's loading actually. Yeah, it's coming. Okay. So this is the supercapacitor. To model this, we need another few blocks like controlled current source. From the foundation library, we will take this. Just let me rotate this. Okay. We need a voltage sensor that will sense the voltage across the supercapacitor. We need one electrical reference. So we have also taken this as well. Solver configuration is by default given in the Simscape blank model. We need a scope. Scope is also given here. We can use this scope as well. We need some constant block. Let me fetch that constant block. Fetch the constant block. Okay. Also, okay. So what we are going to do, we are going to add a constant block, this block in the model, and use an add block to add the step function to the load current block. So we will set the constant value to 25. So let's set the value to 25. We need one add block as well. So let me search here add block. So we find it. What we will do, we will supply this current from using a Simulink to PS converter to this controlled current source here, and this current we will feed it to our supercapacitor. We'll set the parameter after some time for this, and we will just connect these ports here. Also electrical reference, we will connect it here. Any other place you also can connect, it's up to you. Okay. The solver configuration, we will connect it here. We have connected this. So to measure the voltage, we will connect the voltage sensor across our supercapacitor. I have connected it. I need to observe the value. So for that, we need one PS to Simulink converter. We will search for it, PS to Simulink converter. Find it. We'll just take it and we will add it here. Okay. So now we can use a constant block to give the current input. to the supercapacitor. So this one we have taken. Also, we will add some extra current to it. So let's set the value as 30. Okay. We have connected it. Let's connect it here. In the scope, to observe the value, we will use go to and from block. So first, let me add a go to block here. And let me name the go to block as current. Just let me fetch the from block from here so that I can observe the behavior of the current in our scope. I'll connect it here. Just resize it. Okay. Similar way, we will just copy this and we will connect it here and we will change the name as voltage. So as voltage sensor will observe the voltage behavior, sense the voltage behavior. I have named it, and similar way, let me just fetch the from block from this. I'll fetch it. I'll connect it here. Connected this here. Okay. So you can see I have connected all the things. Let me just show the name here also, for all the things. Let me just show the block names. Okay. So let me set the parameters for this supercapacitor. Let me open it. So here in the cell characteristics, we can keep the fixed resistance value as 0.2, 90 and 1000 ohm. Then fixed capacitance, we can keep the value as it is. We will keep the self-discharge resistance as it is. Okay. Then here in this number of series cells and parallel cells, we can keep 1. No issue with that. And here in the nominal values, we will just set the voltage as 600 volt. Okay. I have set it. Oh, sorry. I have set it to 6000, I think. Okay. So you can change it yourself and you can try various parameters to observe different behavior of the supercapacitor. So I have set it. Now let me run it for, let's say, 3000 seconds. I will run it for 3000 seconds. So here I will specify the time, or I can just let me 3500 seconds. If I just click the run button, it will just start run. So it got run, and if I observe the behavior, okay, you can see like this. So what we can do, we can create layout to show two different things in two columns, or you can say two rows actually. And also let me create the legend so that we can identify which one is which. Okay, so here I have not named it, so it is not showing. So here let me name it. So this one is for current and this one is for voltage. So I have named it. Let me run it again. Okay, so I have run it. Okay, I have not saved it. So let me save it again. So I will save in the name of supercapacitor. Here, the save option, you can click in this arrow. Okay, what I have opened, I think, don't know. Okay, so in this save option, you can click and you can click on this save as, and you can name it as ultracapacitor. I have named it and I will just save it because model. Okay, so I have already one model. Okay, let me just change the name to ultracapacitor 1. So I have saved it. Now, if I just run it again, it got run. And if I observe the behavior, You can see the voltage increased from almost 0 to near about some more than 600 volt, and the current is almost constant. Not almost constant, it is constant because I have added here two values of current. One is 25 and another one is 30, so total is 55, so it is constant 55. So what we can do, we can also vary the current here. So I have already some current data for variable current, so let me just take that. So for that we will just delete this constant block, and we will use here from spreadsheet this block. So you can just upload here Excel, where your current will be stored, current data will be stored. So here you can just browse it. So I have saved it under here. So this is in a DC current. Let me just open it. So I have saved it. I will click apply and then OK. It got stored. Now, if I just run it, you can be able to see some variation in the current. So it got run. So you can see there is some variation in the current we got. So there are some pulses as the current is changing. So there is some pulses. Also in the voltage increment, there is also some ripples got introduced as the current is varying. That's why this ripple has introduced. So you can see the voltage is reaches almost 600 volt, some more than 600 volt. So this is the process how we can model ultra capacitor, and so it's very easy using Simscape block set. We can get that built-in model of supercapacitor, and we can build our own ultra capacitor. So thanks for watching this video. If you have any question, please reach out to me. Thank you.